Now we came to spicy stuff. It's trigonometric functions. As we said, trigonometry focuses on relationships between the sides and angles of triangles. So we have some main functions regarding to this topic. So here we have our right triangle, right? So it's 3, 4, 5, as we know, this special triangle. And here the side next to angle X is the adjacent side, and the one opposite to the X angle is called an opposite side. And the one opposite the right angle is called as hypotenuse. So here 5 is our hypotenuse, is here 3 is our opposite side, and 4 is our adjacent side. So let's look at our functions here. Here we have cosinus x, cos x, which is equal to adjacent side over hypotenuse. Okay, our sine x function is equal to opposite side over hypotenuse. Our tangent x is equal to opposite side over adjacent side, and our cotangent x is equal to adjacent side over opposite side. So let's find their values here. So here adjacent side over hypotenuse, which means our cosinus cos x is equal to 4 over 5, right? Our adjacent side is equal to 4 and our hypotenuse is equal to 5. When we want to find our sine x, it's equal to opposite side over hypotenuse. So our opposite side is equal to 3 over our hypotenuse is equal to 5. So when we look at our tangent x, it's equal to opposite side over adjacent side. So our opposite side is equal to 3 over our adjacent side, it's equal to 4. Okay, so when we look at our cotangent x value, the value of cotangent x, it's equal to adjacent side over opposite side, which is equal to our adjacent side here 4, and our opposite side is equal to 3. Now let's look at these examples. In this example, in the first example, we have this shape, and then tangent alpha is asked. So here, to find the value of tangent alpha, the angle of alpha has to be in the right triangle, right? So when we look at here, actually, okay, here this angle is on the right triangle, but we don't know the length of this side. We cannot actually find the length of this side. When I look this triangle also, I don't know the length of this side either, right? Because this is we cannot find the length of this side. So what we can do, actually, we can just make this part like this, and then as you can see here, we get another bigger right triangle, right? So this is also equal to 90 degrees. So we can say that if we say that this is equal to 3x, this is equal to 2x, right? So what was the formula for tangent? It is opposite side over adjacent side, right? So here, let me just like draw here. So this is our 90 degrees, this is our angle alpha, and here we have, let's say here is 2x, this is equal to 3x. So tangent alpha is equal to it's equal to opposite side over adjacent side. So our opposite side, it's 2x over our adjacent side, which is near to this angle, it is 3x. So 2x over 3x, these x cancel out each other, and our tangent value is equal to 2 over 3. Okay, so let's look at our second example. Here we have tangent x is equal to 8 over 15. What is the value of cosinus x? So in this kind of questions, all you need to do is to draw a right triangle. It's very easy to find the answer after that. Let's draw our right triangle here. Let's say this is our right triangle, okay? So tangent x is equal to 8 over 15. So tangent is opposite side. Let's say this is our angle x. So tangent is opposite side over adjacent side, right? So opposite side is 8 and adjacent side is equal to 15. So I can find the value of this side by using the right triangle formula. Actually, this is a special triangle. As you know, it's 8, 15 and 17 triangle. But also we can find, let's say here our h square is equal to 8 square plus 15 square, right? So 8 square is equal to 64 plus 15 square, it's 225. This is our hypotenuse square, and from here h square is equal to 289 and h is equal to 17. As you can see, we found our hypotenuse, which is equal to 17. Now everything is much easier. What was the formula for cosine x? It's equal to adjacent side over hypotenuse. So our adjacent side is equal to 15. It's 15 over our hypotenuse, it's 17. So from here we get our answer as 15 over 17. Now here we have a very useful rule, as we know that complementary angles are the set of two angles such that their sum is equal to 90 degrees, right? For example, 30 degrees and 60 degrees, they are complementary to each other as their sum is equal to 90 degrees. So here x is the complement of y and y is the complement of x. So in these kind of situations, here we have these equations. Sine x is equal to cos y and tangent, this should be tangent x, of course. This is tangent x is equal to cotangent y. So in a right triangle, as the measure of the right triangle is fixed, it's 90 degrees, the remaining two angles are always complementary as the sum of angles in a triangle is 180 degrees. So if we say that this is our right triangle, okay, since it has 90 degrees, so this x and y, the sum has to be equal to 90 degrees, right? This has to be like this. So I want to show you why these are equal to each other. So here sine x is the opposite side over hypotenuse, right? So let's say here a, b, c, okay. So sine x is opposite side over hypotenuse, so it's equal to b over c. Cosine y, it's equal to adjacent side over hypotenuse, so which is equal to also b. Of course, adjacent side is the one next to y. It's b over hypotenuse. It is c, right? As you can see, these are all equal to each other. So that's why this comes from this mentality, this logic. So it's also same for tangent and cotangent. So let's look at these values. Here we have sine 30 degrees, which is also will be equal to cosine 60 degrees, since they are the complement of each other. So here we have cosine 20, which is equal to sine 90 minus 20, it is 70, right? Sine 70 degrees. So here we have tangent 40 degrees, so which means this is equal to cotangent 19 minus 40, it is 50. So this is equal to cotangent 50 degrees. So in this example we have ABCD is a rectangle, the length of BE is equal to 10, the length of AB is equal to 20, sine alpha is asked. So sine alpha is equal to opposite side over hypotenuse, right? Let's look at our alpha angle here. So we don't know the opposite side, we just know the hypotenuse, but we cannot find this side also. So what can we do? If we draw another angle here, and let's call it as beta, okay? So here, as this is a rectangle, right? So it all has to equal to 90 degrees, right? Also here, alpha plus beta is equal to 90 degrees, right? So now we can use that rule with complementary angles. So these are the complement to each other. That's why we can say that actually sine alpha is equal to cosine beta, right? Because when you look at here, in this right triangle, we know all the sides. We can also find this side very easily. So that's why it's very easy to find the value of cosine B, which is also equal to sine alpha. So let's do that. How we find the value of cosine? It is equal to adjacent side over hypotenuse. So here our adjacent side is equal to 10, right? So this is equal to 10 over our hypotenuse, which is equal to 20, right? So it's 10 over 20, which is equal to 1 over 2. So this is our cosine B value, is also our sine alpha value, which is our answer here. So in this example, we have ABCD is a square. The length of AE is equal to 3 times the length of AC. So the tangent alpha is asked here. Okay, so when we look at our angle alpha here, we see that it's not in the right triangle, right? So we will try to draw some right triangles in order to find to the value of tangent alpha here. So let's start with this given information here. So if we say this length is equal to x, so the AE will be 3x, right? So if we say this is equal to x, this will be equal to 3x. So since this is a square, okay, which means here is 90 degrees, all angles are equal to 90 degrees, and all these lengths, they are all equal to each other, right? So we have here 90 degrees and we have here these lengths which are equal to each other. So this is an isosceles triangle, and if I draw a median from here, okay, and from here, let's say I draw like 90 degrees here, okay, this will split the opposite side in 2 equal parts. So since here the total is 4x here, right? So this is 4x, and this will split these 2 equal parts. This will be the length of here will be 2x, and also the length of this would be equal to 2x. Since this is equal to x, this EC is equal to x, which means this length here is equal to x, right? Because this is 2x, x, and x. This is all equal to 4x here. So as you can see, we created a right triangle here, which also includes our angle alpha. So also another rule about these this kind of triangles, if this right triangle split this side into 2 equal parts, which means this length also is equal to these lengths, right? So let's do that. If this is 2x and this is 2x, which means this length also is equal to 2x. So let me draw here actually to see it better. So this is our right triangle, okay, this one. So when I draw this 90 degrees here, okay, this would be like this. So tangent, now we are able to find the value of tangent alpha. So tangent alpha, which is equal to opposite side over adjacent side, right? So here our alpha degree here, our opposite side, which is equal to 2x, over our adjacent side, which is equal to next this angle, it is here, as you can see, it's x. So from here, when these are cancel out each other, and our value of tangent alpha is equal to 2.